So to start off with, we're going to have some learning objectives we want to get through today. We're going to start off by stating the Viessmann recommended maintenance interval and control setup that will result in a maintenance alert. We're going to list the recommended chemicals and tools to clean the heat exchanger, and we're going to describe the required annual maintenance procedure and illustrate a proper combustion analysis. So to start with, everything covered today is out of the installation and service instructions, and that can all be found in our Pro Toolbox here. Lots of really good stuff on the Pro Toolbox. We've got a fault code checker, we've got tech support, all that kind of stuff. So highly advise clicking that QR code, and when the presentation's done, you can have a look through old manuals, new manuals, lots of really good stuff on there. So to start with, the presentation we're going to cover today is going to cover the 100 and 200 series family. Just to do a little introduction to those two boilers, we've got the 100 series and the KE, so the Combi family. We've got the small chassis in the 120 and 199,000 BTU. And then we've got the 100 series heating only small chassis 85 and 120 and large chassis 150 and 199. Of course, we can still do domestic with the heating only. We're just going to have to pair that with one of our indirect tanks. And then we've got the B2HE family here, also in the small chassis 85, 120 and large chassis 150 and 199. The 200 is kind of the big brother of the 100 series. You get a few little extra bells and whistles, and it's going to do kind of a more broad range of applications and some different temperature ranges and things. So for the presentation today, we will be covering annual maintenance on these two families of boilers. And just a warning here, I know we've all seen this message probably before and told our customers this, but if you don't schedule time for maintenance, your equipment will schedule it for you. And in my experience, that's going to be, when it's minus 20 outside and at 2 a.m. So let's schedule proper maintenance, and we won't get those nuisance calls, and we'll extend the life of our boiler. So to start off with, the easiest way to schedule our maintenance intervals is during commissioning. So during the commissioning process, close to the end of the commissioning process, you're going to get a screen like this on the 100. And we will be kind of flipping back and forth here between the settings from the 100 series and the 200 series, just so everybody gets a good example if they've got a 100 or a 200 series. So at the end of commissioning on the 100 series, we're going to get the maintenance interval question here. And we're going to have three options. We're either going to schedule it for off, which we don't recommend, 3, 6, 12, 18, or 24 months, or we can schedule it for burner run hours. So maybe the boiler is in an application where it's running a little more than in a regular family dwelling, and you want to schedule it for a burner runtime rather than the monthly interval. But here at Viessmann, we do advise doing the 12 months. So we do an annual maintenance. It's good to check all of your gas appliances at least once a year. And then moving over to our 200 series interval, maintenance intervals. So same thing, during commissioning, we're going to get a screen like this. The 200 has a little bit nicer of a display screen, a little bit bigger. It's a touch screen. It's all in color. So you'll notice when we're flipping back from the 1 to the 200, this nice color screen is on the 200 series. And again, we're going to get the same options. We're going to get the months or the burner run increments, and we suggest the 12-month increment on that. So maybe you didn't commission this boiler, maybe you didn't install it, and you're showing up to a home where you're going to get a maintenance contract and they're going to become a regular customer, and you still want to set a maintenance interval. Well, we can go into the coding parameters, and we're going to follow this path here on the bottom for the 100 series. That's going to bring us into the coding parameters where we can either set the 521 VDD for hours, or we can set the 522.3 VDD for months. There's the what the screen's going to look like once we pull that up on the 100 series. And again, we do always recommend annual maintenance for these guys. And then jumping over to the 200 again, this is what the screen that you're going to see on the 200. Same idea, we've got the 521.0 for our hours in runtime, and we've got the 522.3 interval for the months. And there's our path to find that in our HMI, or our human machine interface. And again, we recommend that 12-month interval. So here's what it's going to look like in our service manual. So you're going to have these options here for the burner run hours. You've got 0 to 25,500 hours. I don't recommend that. That's going to be just about 3 years. I think it's about 2.9 years actually. And then we've got these for the month settings, we have these numbers correlating to the months on the right. So that 12-month increment that we always like to suggest is going to be a number 3. And something to remember is these boilers have a light guide trigger built into them. So not only can you schedule maintenance with your homeowner or with the boiler, the owner of the equipment, but the boiler is also going to give the homeowner or the owner a signal with the light guide when it is time for maintenance. And also the boiler will be monitored with vGuide and will communicate the maintenance interval as well. So if you're monitoring your customer's boiler with vGuide or the customer's monitoring it with a vCare, 2 really great apps that we offer, then that's also going to trigger a maintenance interval alert. So let's start off with some required tools and equipment to do the maintenance on these 2 boilers. We've got our adjustable wrench. We've got our Viessmann cleaning tool. We got a part number here for that cleaning tool. This is a tool that has been designed specifically by Viessmann to get into the windings of this boiler in the heat exchanger. We've got a hard bristle nylon brush set for those that more frustrating stuff to get off that heat exchanger. And we've got water. Hopefully we have water access on site. It's it's a lot easier to maybe have a hose bib and have a good amount of water there rather than a bottle as we've got displayed here. And then we've got Axiom Industries Clean F Steel. This is just an example. This isn't a requirement. You can use citrus surf or really any chemical cleaner that is a phosphorus or citrus based cleaner. Anything really that's safe for that stainless steel. And then of course we got our Torx bit set. And then continuing on, we've got a combustion analyzer. We're going to want to do a proper combustion analysis once we have cleaned up this heat exchanger and done our maintenance. We've got our manometer. We're always going to want to verify our static and dynamic gas pressure. We got our wet dry vac to pick up all the water and debris and things that we might get out of the heat exchanger, as well as cleaning around the cabinet and around the boiler. And then we've got our Allen keys, 6 mil, 6.5 mil, 10 mil, and 12 mil. And then we've got our trusty multimeter. Now you may not need this for the maintenance per se, but it is always recommended to have your multimeter with you anytime you're disassembling any piece of equipment like this. You never know when you're going to need it. And you may need to test some safeties or some circuits once you're done the maintenance there. So if you notice, we jumped from required to recommended. This is the Viessmann toolkit. There's the part number there that I'm just circling with my laser. This is a really convenient toolkit. It comes with everything that you need to complete a maintenance on this boiler. We've got our screwdrivers with a really nice extension that fits in the whole length of the handle of the screwdriver. We've got a few other screwdrivers, our sockets, our torque bits, and our Allen keys here. So really nice, convenient toolkit, convenient carrying case. So if you don't have one, I recommend checking them out because they're a pretty cool little kit. And then we also have our maintenance kits that you might want to pick up before you go and disassemble the spoiler. We've got our small chassis maintenance kit here, the part number, and we've got our large chassis maintenance kit part number here. And with that, you're basically going to get our ignition rods here. We're going to get our ionization or our flame rod. We're going to get some new screws to fasten these down. We're going to get new gaskets for each electrode. And then we're also going to get a new gasket for the connection before the gas valve, which we'll have a look at in a little bit. So to start off, we're going to remove the HMI for service. This can be either on the top or bottom of the cabinet, and it's going to be a lot easier to work in the cabinet with it removed. So we'll start off with turning off the power. We're going to turn off the gas, remove the HMI, and place it in a safe place. So this faceplate here is just going to pop off. Really easy, and you just want to put that in a safe place. It's where you're going to input all of your navigation through the boiler and all your data points and everything. So we don't want that to get damaged. Let's take it off, put it aside, and then you're going to be left here with just the carrier. So we're going to remove the HMI carrier by releasing some tension clips. These clips up here on the side, we just pop them out with our fingers there, and the entire carrier just pulls up and out. Then we're going to remove our electrical connection on the back. And once we have it removed, as you can see, we've got full access to the entire cabinet here. It's going to make the maintenance much easier. I'm not sure if I would ever even think about taking this thing apart without removing that, but so once we got the carrier removed in the HMI, this is what it looks like. We've got our small chassis boiler here, and we've got the power turned off, hopefully already. We've got the gas turned off already. So we're going to start by disconnecting cables and leads off of the burner and fan assembly. So we'll start with the fan motor. Then we're going to disconnect our ionization electrode, followed by our ignition unit, and finally our ground wire there on the side of the main burner plate there. So then we're going to undo the gas supply fitting with our adjustable wrench there. And then we're going to undo the 4 screws and we'll be able to pull the burner out after that. Something just to make note of, we want to always cover our gas connection. As you can see here, this is a vertical connection. So it's a good idea to cover that with a cloth or a glove or something like that. We don't want any debris or dirt from the heat exchanger falling down into that gas line and possibly getting sucked up by our blower and pulled into the gas valve and all that. There's that there. And there's that extra gasket that we supply with the maintenance kit. So we do recommend changing this annually when you break this connection. If for some reason you don't have it, then obviously you do your due diligence, maybe do a soap test and a leak check and make sure that once you fasten that back up that we're not going to be leaking any gas anywhere. So next we've got the large chassis here. So very similar idea. The heat exchanger is much larger. It takes up a lot more of the cabinet. So our instructions here are the exact same on the left. The only difference is our gas supply fitting is a little different. It's going to be coming in on a horizontal instead of a vertical. So we don't need to necessarily cover it, but I would still take some precautions that you don't want to get anything in there, cover it with something. And then we've got our 6 screws holding the burner in instead of 4. And that's the main difference between the small and large chassis for pulling that. So next we are going to jump back to the small chassis and we're going to remove the torque screw while holding the flame body. We're going to remove the flame body and insulation ring and check for damage. So as you can see here, this is all pulled apart. We're going to check this insulation ring for any cracks, any splits, anything like that. Then we're going to check the condition of the burner gasket and note the alignment of the tab here. And this little tab here, we'll see in a future slide, but we want to make sure that this lines up with our little keyway here. And we want to make sure that the gasket is in good shape. So we're going to kind of bend it and fold it around, make sure it's not dried out, make sure it's not cracked. And then after that, we're going to clean our ignition and our ionization electrodes and reinstall that gasket. There that is, pointing that tab out to you guys there. So we want to make sure that we've got that tab in the correct orientation there. And then we're going to reinstall that insulation ring in the flame body, and we're going to check for a nice firm seating. And as always, we're going to do our due diligence here. Anything that's damaged or worn, we're going to replace it. And then continuing with the small chassis, when we're reinstalling the flame body, we want to note the keyway on the burner on the bottom here. And that is going to be installed on this little nipple right here on the burner door. And proper alignment of that is very important. If that is not properly aligned and you have a gap in there, not only are you going to get flame failures, but you're also going to have a flame possibly shooting out of there. It's going to create hot spots and all kinds of stuff. Definitely not good for the boiler. So we want to make sure we align those keyways. And so next on the large chassis, disassembling the burner, it's a very similar process, but we're going to loosen the 3 hex screws to remove the insulating ring. And again, if you notice the socket here, all these sockets and everything are included with the Viessmann toolkit that I mentioned earlier. So once we got it apart, we're going to do a similar inspection. We're going to check our insulating gaskets there, but we're also going to loosen 4 torque screws and carefully remove the flame body for inspection. Now, you're not going to have to do this with every single maintenance. If this boiler is set up properly, if we've got our heating curve set up properly and we're getting lots of condensing on this thing throughout the year, with all that condensing, the heat exchanger is going to stay a little more clean. So if you're going to remove the burner or not, that really depends on how hard the boiler has been working and whether it's been working properly in the application it's been installed in. So we're going to check the condition of the burner and door gasket, and we're going to note that orientation of the tab there again. We're going to reinstall that burner with the 4 torque screws, and we're going to torque those to 40 inch-pounds. So we've got a few torque recommendations on this boiler. So if you don't have a torque screwdriver or a screwdriver that can torque to a specified inch-pounds, then I recommend getting one for these maintenances. We're going to install the burner door gasket, again, aligning that tab properly. We're going to place the inner and outer insulation mats in the burner door, insert the insulation ring, and ensure that the insulation mat is not under the 3 supports. So the 3 screws that we took out to remove this, we want to make sure this is all seated properly, because again, we're going to have burner problems and hot spots and things like that if we don't get that seated properly. And then again, we got another torque here. So we got the 3 hex screws to secure this, and we're at 35 inch-pounds for that. And again, of course, replace all damaged or worn parts as needed. So next we're moving on here to the ignition and ionization electrodes. We've got a little bit of a legend here. So we've got A showing our ignition electrode. We've got B showing our ionization electrode. And then we're going to have our gaps. We've got our ionization electrode gaps. We've got our small chassis, our large chassis. So C is showing us that here. Then we've got our ignition electrode gap being shown by D. And take note, the Allen keys that I specified in the beginning, we've got the 10, the 12, the 6.5, and the 6. These can all be used to check our gaps here. So if you've got your standard Allen key set in your bag or in your Viessmann toolkit, we're also going to tighten these screws to 40 inch-pounds. Another torque's there. We need another torque specification there that we need to remember and make sure we torque these down to that rating. But if we've got our Allen keys, our standard Allen key set in our bag, we can use all of those to check our gaps. So really convenient. You keep those Allen keys for these maintenances, and we can do all of our gap checks with those standard size Allen keys. Makes it really simple. So moving on to clean the heat exchanger. The first thing we're going to start with, we've got the burner removed. To clean the combustion chamber by brushing and vacuuming any loose debris that will easily be removed. And then we're going to clean embedded debris by flushing it with water. Again, hopefully we've got water access. Having a hose or something like that is going to make this a lot easier than just having a bottle of water or something like that. And then if needed, we're going to use our Axiom Clean F steel or Citrus Surf 77 can be used if required, or again, any chemical cleaner that is phosphorus or citrus based. And then we're going to use our Viessmann cleaning tool here. Again, here's our part number here to remove any debris between the coil windings. So this tool has been specifically designed to poke in between the tiny gaps in between these windings here. So really great tool for that. Highly recommend checking that out. And then we're going to flush our combustion chamber with water until it runs clear through the condensate trap. And we want to avoid getting the refractory wet. And on that note, the refractory can be removed. So we'll have a look at that in a sec. But a big note here, don't scratch the heat exchanger surfaces and do not use metal wires or brushes. If you scratch up this stainless steel, it is really going to impact the life of this heat exchanger. So, if you do have to take a brush to it, use the nylon brush that we've recommended, a hard bristle nylon brush. Don't use a metal or wire brush. But back to the refractory getting wet. The refractory can be removed. So the easiest thing, we've got some guys, they want to cover it with like a pie plate or a piece of plastic or something like that when they're doing their cleaning. But we got one screw right here holding it in. You pop that screw out and the whole refractory comes out. If these refractories get wet and water gets into them and they're not perfectly dry when the burner fires up again, you're going to get water bursting into steam and you're going to damage the refractory. So one screw, it's really not worth risking damaging the refractory. Let's pop that screw out and pull that refractory out. And then what you'll see behind the refractory here is the center plate, and it's a fixed center plate. The section behind it is a maintenance-free area, so you don't have to worry about getting any farther into this or anything behind the center plate there. So next up, we've got the condensate trap service. So we want to remove the siphon trap, and we want to flush it and clean it and flush it with water till all the grimy stuff is out of it. Really easy removal. This clip here pops off really easy. Stick your thermostat screwdriver in here, turn it 180 degrees. It pops the clip. You lift it off, and you can lift this whole thing right out of it and clean it in a mop sink or the closest area that you can get access to water. So we've also just cleaned the heat exchanger. So we want to make sure that the condensate line has no bends or traps in it. We want to make sure that all that grime and dirt and debris we've cleaned out of that heat exchanger has been flushed completely through the condensate line and completely through the condensate trap. And as always, we do have a very secure box for our electronics underneath the heat exchanger and just on the side of the condensate trap. But again, it's do your due diligence, and I like to go the extra mile and cover this with maybe a towel or something, just so we're not dumping water over the control boards or possibly getting anything in there. And then once we've cleaned the trap out, we're going to fill it back up and refit it, making sure that all the connections are nice and tight. We don't want any water leaks. And just on the bottom left here, there's a picture of our nice clean trap, all nice and reinstalled. And then continuing on with the condensate line, farther down from the trap, we're going to have our condensate neutralizer. This is a pretty straightforward clean for this thing. We want to make sure that it is not plugged up. We want to make sure it's not all grimy. And we also want to make sure that the granulate inside the box hasn't all stuck together and formed one big rock. So you really want to take the granulate out, give it a rinse, top it up if you need to top it up. Take it all out, clean it all out, give the box a really good rinse, a really good clean, and reinstall it all and give it a test afterwards and make sure that it's doing what it's supposed to be doing. So we can use a pH strip like we've got here, or we can use litmus paper or an electronic pH analyzer. Lots of little methods for testing these. So use one of these methods and make sure that we are actually neutralizing that condensate to that 7-8 pH that we want. And so we always say, putting the burner back together and all that stuff is just doing the disassembly in reverse. So here we go. We're going to do the small chassis. We're going to insert the burner assembly. We're going to tighten the 4 torque screws diagonally to 35 inch-pounds. Again, another torque number there that we need to remember. And then we're going to fit the gas supply pipe with a new gasket. Like we said earlier, we want to make sure that the gasket is in good shape. So that comes with those maintenance kits that we discussed earlier. We want to ensure it's tight and we've got no leaks on it. They're going to reattach all of our cables. And same process with the large chassis. Once we've got the burner and everything reassembled, we're going to insert the burner assembly back into the heat exchanger, tighten our 6 torque screws diagonally to 35 inch-pounds. And then again, we're going to fit that gas supply pipe with a new gasket and tighten that to 22 inch-pounds. Ensure that gas connection is tight and reattach our cables. So next, we've done our maintenance. The boiler is nice and clean. We've got the burner reassembled, reinstalled. All of our wiring connections are connected, and we're ready to fire this thing up. So what we want to do now is check our static and dynamic gas pressure. If we're dealing with natural gas, we want that 4 to 14 inches. If we're dealing with the liquid propane, we want that 10 to 14 inches. To start with, we're going to shut off our gas, and we're going to loosen the needle valve on our gas test port here. We're going to hook up our manometer and open the gas valve to check our static pressure. So what we see here, we've hooked up our gas pressure, or our manometer, sorry, and we've got 11.193 inches water column. So now we know our static, and we want to check our dynamic. So we're going to fire the boiler. We want to ensure we've got less than a 1-inch pressure drop. So for easy numbers, if this is 11.2 and we fire this boiler and it drops anywhere below 10.2, we may want to do some checks on our gas line. It could be sizing of the gas line. We want to check our regulators. It could be as simple as, over the summer, maybe some bees or some wasps made a nice nest in the reg vent or something like that. So we want to go check that out, and we want to ensure we don't have more than a 1-inch pressure drop across the from static to dynamic pressure. Once we've tested our gas pressure and we know that we have we're within the minimum and maximum range and we have less than a 1-inch pressure drop, then we want to do a combustion test. Now, modulating boilers require a combustion test at both low and high fire. And we're going to utilize the actuator test that is on board with the HMI to to complete that combustion analysis. So we're going to go to our actuator test in our service. We're going to check to burner modulate, and we're going to complete our combustion test in both minimum and maximum heating outputs. As you can see here, we've got our minimum and maximum selection on the HMI. And then over to the 200, same idea. We need to do our low and high fire test. We've got our bit bigger, nicer screen here in color, but we still have our same actuator test in our service menu and our burner modulation target value. So we're going to complete that in our low and high fire, and then we're going to do our combustion test. So for our combustion analyzer, we're going to stick it in port A here and complete at both low and high fire. And here is the range we want for natural gas and liquid propane gas. So CO2 or 6.9% to 11%, O2 2.1 to 8.4%. Our CO2 for liquid propane is going to be 8.3 to 12.4, and our O2 is going to be 2.1 to 8.4. Our CO, we don't want to exceed 400 parts per million. If you've done a good job in your maintenance and that heat exchanger is nice and clean, we're going to most likely see much, much less than that. If you do exceed that, though, you may want to do some checks, and maybe that's a time you want to go on that Pro Toolbox and call tech support. We're going to reseal the test port after the combustion analysis. Something also to remember is our onboard combustion management system, Lambda Pro Plus. It is going to calibrate every single time we cycle the power on this boiler and almost every single time we start it up. Our manual states that we want to wait at least 50 seconds from the burner starting to putting our combustion tester in here. So I'd give it a minute or two. We don't want to get that, initial puff of carbon monoxide, and while the Lambda Pro is calibrating, it goes to that high and low end. So you're going to get some mixed readings that really aren't going to help you. So you don't want to damage your CO sensor and your combustion analyzer. So let's wait that minimum 1 minute. I'd give it a minute or two before we stick our probe inside the vent. Once we're done our combustion analysis, we can also check for flue gas recirculation. This is for a coaxial venting. So we're checking CO2 in the combustion air intake. So on the other port that we did our analysis in, this is that kind of that dead interstitial space that brings in our intake air. An easy way to do this, we stick our combustion analyzer in there, and if we've got less than 0.2% CO2 or more than 20.6% CO2, we may have flue gas recirculation there. And in that case, we're going to thoroughly check the venting system, make sure that we are following the code for distances. Make sure we're not installed in a location that might be pulling in the flue gases from another appliance, all that kind of stuff. And once we're done, we're going to reseal that port. And then if we do have a two-pipe system, we've got our exhaust coming off and you've either chosen to use the left or right port for your combustion air, then we're just going to drill a hole in the intake air pipe and we'll do our test that way. Once we've completed all this and we're all ready to roll, we do want the maintenance interval to be reset. We want our customer to be alerted. We want our V-Care or our V-Guide to be alerted. So for the 100, we're going to go in to the service menu and we're just going to click reset maintenance. And it's going to tell you maintenance interval is reset. Okay to confirm. Easy as that. On the 200, very similar. We're going to go into our service functions and we're going to reset the maintenance. Something to note, the reset maintenance option is only available on the 200 once the maintenance interval has been met. So if you haven't met the maintenance interval, this little tile isn't going to be there. But what we can do instead of that is go into our VDD settings like we showed at the beginning, the coding parameters, and we can choose a different maintenance interval. So we'll jump it down to 3 months, put it back up to 1 year, and that's going to reset the maintenance interval manually if we have decided if our technician has come early and we've done our maintenance maybe a couple weeks early or a month early, then we can get around that by doing that.
And we'll see you around next time.
Thanks for attending, everybody.